Okay, so this is for section 6.1. This one topic here is dealing with the empirical rule and applying the mean and standard deviation. So each one of these are topics that we're going through in 6.1 look at application of knowing what the mean and standard deviation are and how to apply that, in this case, to a bell-shaped curve. And basically the empirical rule says this, that if we know we have a bell-shaped curve, we can apply the mean and standard deviation this way. That, for example, that if we know that the mean is a certain number, and I'll go through that down here at the bottom, if we know that the mean is 100 and the standard deviation is 15, looking at that for IQ scores, then what we do is in the middle we anchor down the 100 and then start counting by the standard deviations, which is 15 points. So the first rule here says that if we lie within one standard deviation of the mean, then that represents 68% of the data. So let's go ahead and do that down below. That in the very center, I'm going to put in that 100, and then we're going to count by 15. So I'm just going to add a 15 to that and make that up to 115 IQ points. Then I'm going to subtract and go back the other way and minus 15 and make that 85. So again, what I did here was I put the mean in the center. So there's our mu, but then what I want to do is add a standard deviation, which is 15 points, and then back the other way, subtract 15 points to get those two numbers. By the empirical rule, it says up here that if that's the case and we have a bell-shaped curve, this interval between 85 and 115 is representative of 68% of the data. But let's keep going with that concept, working with that standard deviation of 15. So the next one here says about 95% of the x values lie within two standard deviations of the mean. So if we were to do that another time here, making that a total of twice, let me go ahead and add. Let's add another 15 and subtract another 15 that represents that standard deviation. So here we add another 15, it makes that 130 points. And then if we subtract a 15 from 85, that'll make that 70 points. So we have here up to 130 points and then 70 points. By the interpretation of that, we're trapped here between 70 and 130. If that's the case, then that represents 95% of the data. So again, 95% of the data is between those two values. And again, assuming a bell-shaped curve. The last bit there is going to deal with 99.7% that we know if we did that one more time, then we'd have almost 100% of our data. And here to emphasize here that 99.7% is almost or just up to 100%. So I really don't want to go count more than 3 standard deviations, even though you could. So let's go ahead and do that one more time here. Let me go ahead and add 15 points and subtract 15 points. If we went ahead and added 15 points, then we get up to 145 IQ points, and then minus 15 with that, we get 55 IQ points. So those are kind of extreme ends there, being the lower bound, the upper bound, and that then between those two numbers represents almost everything. 99.7% of all data collected is between those two values. That's only true if we have a bell-shaped curve and we know that our parameters, the mean and standard deviation, are correct. Otherwise, if anything of that nature is off, then the empirical rule doesn't hold up to be true. So let me zoom out just for a little bit here using this example to iterate for the empirical rule. It's basically our 3 percentages here called the 68, 95, 99% rule, and that's outlining within 1, 2, or 3 standard deviations within the mean. You can certainly go more standard deviations from the mean if you wanted to do that, but the point here is that you basically want to stop at 3 standard deviations. And another thing to point out, if you go beyond 3 standard deviations, that can occur. It's just extremely rare. And we're going to talk about that later when we get into chapter 9.